Hiya folks, Root Beer here, looking at question number 22, our second Part C question on the Grade 8 Gauss from 2009. A dollar sign is formed by drawing two parallel vertical lines through the letter S as shown. Yeah, there's the dollar sign. Okay, incidentally the cent sign is a letter C with one vertical line through it. Okay, and for those of you over in Europe, a euro is essentially a C, but it's really an E with two stylized parallel lines. Kind of cool. It almost looks like an epsilon almost. Anyway, okay, that's what a dollar sign is. Two parallel vertical lines drawn through the letter S. These lines cut the letter S into 7 pieces. 1, 2, 3, 4, 5, 6, 7. Hey, they were right. It's almost like they reviewed the contest. What is the minimum total number of parallel vertical lines that are needed to cut the letter S into exactly 154 pieces? Okay, 154, that is a lot of pieces. A lot of pieces. So I'm probably not meant to just sit here drawing vertical lines. But, maybe I can start off the question drawing some vertical lines and see if I can maybe notice a pattern. So how about we skip over to our notepad here. And if we start with, here, I think I'm going to make a little table here. So number of lines, and then number of parts or segments of S. So if I've got 0 vertical lines, I've just got an S, and so that's one whole S. If I've got 1 vertical line, well, 1 line comes in, and let's use another color here. Splits it into 1, 2, 3, 4 parts. Now, 2 vertical lines. We'll draw it a little bigger. But as has already been remarked, we get 7. 1, 2, 3, 4, 5, 6, 7. All right, let's try 3. Draw it a little bigger, and maybe make my S a little fatter, just so I can really tell what's going on here. And you can keep drawing these as much as you need to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But eventually, you should notice a pattern. I'll do one more, and then we'll talk a bit more about this. I'm making my S's a little fatter just so I can fit in the lines, but it's still hopefully visible to you unless you're looking at this on a very, very low resolution monitor. 1, 2, 3. How many? 4, 5 segments. 6, 7, 8. There are 9, 10, 11, 12, 13. Okay, so let's just take a moment. 1, 4, 7, 10, 13. You might even begin to guess what the next one is. 16. We could even draw it out. But what's happening? What's happening when we do this? And how can this help us? Well, imagine that we had so many vertical lines. And, it's got, let's say, X segments. X is just some number. What happens when I come in with another line, maybe this red line? And I can place it wherever I want. I'll just do a red vertical line here. Well, these 3 lines that were 3 different segments have now been split into 2. 1, 2, 3, 4, 5, 6. So what it effectively does, this vertical line, is wherever it happens to be cutting, it cuts 3 segments in half and adds 3 new segments. And that's why we're going up by 3 each time. Now, if you want an actual formula, if, say, n is your number of lines, then 3 times n plus 1 should do the trick. So how did I do that? Well, the 0 doesn't mean anything, so anything times n is 0. And then I just added 1, but you can check 3 times 1 plus 1 is 4. 3 times 2 plus 1 is 7. By no means should you be getting it that quickly, but, you know, if you played around with figuring out patterns and sequences before, you're all set. Okay, so n is the number of parallel vertical lines we need. And how many segments do we want? 154. So 3n is 153. And so n should be, just dividing by 3, and grab your calculator if you need to, but we should have 51. 51 vertical lines should give us 154. Okay, and 51 is right there. It's D. So that's what we're going to do now. It was a little cramped, so thankfully for question 23, we're going to move over to the next page. Thank you guys so much for watching. I will see you for question 23 in the next video.